So let's look at some inverse properties of our trigonometric functions, right? And these are going to be related to inverse operations, okay? We've talked a lot about inverse operations. You've done so in the past in your algebra classes. Remember, the key thing about inverse operations is they cancel out. The inverse operation of multiplication is division. Division undoes multiplication. The inverse operation of subtraction is addition. Okay, addition undoes subtraction. The inverse operation of taking a square root, that's going to be squaring. Okay, the inverse operation of taking a natural log, that's going to be exponentiating with the base of e. Okay, those are examples of inverse operations that we have already studied throughout this year. Well, here we introduce a few more. If -1 is less than or equal to x, which is less than or equal to 1, and negative pi over 2 is less than or equal to y, which is less than or equal to pi over 2, then the sine of the arcsine of x is equal to x, and the arcsine of the sine of y is equal to y. Notice, taking the sine of inverse sine, those are inverse operations of each other, and inverse operations cancel out. The arcsine of sine y, again, we are taking inverse operations, they cancel each other out, and leave us with y. One thing to make note of is these values of x and these values of y, okay? These properties are only true if x is between -1 and 1, and that's because I can only get out a sine value that is between or equal to -1 and 1. That's the range of my sine function. Similarly, y must be between negative pi over 2 and positive pi over 2, because that is the range of our arcsine function, okay? I can only get out values between negative pi over 2 and pi over 2 for arcsine. If -1 is less than or equal to x, which is less than or equal to 1, and 0 is less than or equal to y, which is less than or equal to pi, then the cosine of the arc cosine of x is equal to x. Again, inverse operations cancel each other out. We take the cosine of arc cosine, we cancel it out, we're left with x. The arc cosine of the cosine of y, inverse operations, they cancel out, and we are left with y. Now, again, this is only true if x is between -1 and 1. And that's because -1 and 1, well, that's the range of our cosine function. If I'm taking the cosine of anything, I got to get out a value that's between -1 and 1. Similarly, y has to be between 0 and pi in this case, because if I'm taking the arc cosine of something, remember the range of our arc cosine function is from 0 to pi. And finally, if negative infinity is less than x, which is less than infinity, and negative pi over 2 is less than y, which is less than positive pi over 2, then tangent of arctan of x is equal to x. Again, inverse operations canceling out. And arctan of tan y is equal to y. Inverse operations canceling out. Key things. X. Well, this applies to all real numbers, because my outputs, my range of my tangent function, if I'm evaluating the tangent of something, I can get out any real number. X is between negative infinity and infinity. Y must be between negative pi over 2 and positive pi over 2, because my range of my inverse tangent function is only values between negative pi over 2 and pi over 2. I only get outputs between those two numbers. All right, let's see if we can't put these inverse properties to use. Evaluate the following expression involving inverse trig. And again, you've seen this image before. Here we have the ranges of all of our inverse trig functions. In blue, the range of inverse sine is negative pi over 2 to pi over 2. In green, inverse tangent, negative pi over 2 to pi over 2. And in red, the range of our inverse cosine function, 0 to pi. All right, we have the tangent of arctangent of 45. Well, tangent of arctangent, those are inverse operations of each other. Notice that 45 is within the range of our tangent function. Therefore, our answer is 45. The cosine of the inverse cosine of -1/2. These are inverse operations of each other. Notice that -1/2 is in the range of our cosine function. The range of cosine is -1 to 1. Therefore, we simply say those cancel out, and we are left with negative 1/2. The arc sine of the sine of pi over 2. Well, arc sine and sine, inverse operations. Pi over 2, we come over here to the unit circle. Notice that is within the range of our inverse sine function. Because it's in the range of our inverse sine function, our answer is simply pi over 2. And the inverse tangent of the tangent of negative pi over 6. Well, if we look at inverse tangent, the range for inverse tangent is negative pi over 2 to pi over 2. We're looking at negative pi over 6 here. Negative pi over 6 is certainly within that range. Therefore, our answer, those inverse operations cancel each other out, and we are left with negative pi over 6. Let's take a look at another one here. The inverse cosine of the cosine of 7 pi over 2. Now, we see an inverse cosine, we see a cosine. We need to think about inverse operations. However, let's look at the range of inverse cosine. Inverse cosine is only going to give out an angle between 0 and pi. Notice that our angle here, 7 pi over 2, is not between 0 and pi. Right? So it's impossible to get out 7 pi over 2. Instead, however, we can just think about evaluating this using order of operations. Okay, let's simplify the cosine of 7 pi over 2. Notice 7 pi over 2, that's 3.5 pi. So if we come over to the unit circle, there's 1, 2, 3.5 pi. This is where 7 pi over 2 brings me to. The cosine of this angle, cosine corresponds to the x-coordinate, would be 0. So this is actually the inverse cosine of 0, which now I need to find the angle between 0 and pi that has a cosine of 0. That's what this is saying. And our answer is pi over 2. Let's try another one. Cosine of the inverse sine of root 3 over 2. Now, not inverse operations here, so we can't just cancel them out. But again, we can use order of operations and work from the inside out. The inverse sine of root 3 over 2. This is the angle that has a sine value of root 3 over 2. Well, my range for inverse sine is negative pi over 2 to positive pi over 2. Which angle between negative pi over 2 and positive pi over 2 has a sine value of root 3 over 2? Pi over 3. So this is the cosine of pi over 3. And to evaluate the cosine of pi over 3, we need to find the corresponding x-coordinate, which is 1/2. All right, and one more example here. The inverse tangent of the cotangent of 7 pi over 4. Well, again, we can start off talking about order of operations and just work from the inside out. Like, there are no inverse properties that are going to cause anything to cancel out here. Okay, so we need to evaluate the cotangent of 7 pi over 4. Well, where's the angle 7 pi over 4? You can just count them out. 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. There is the angle 7 pi over 4. All right, cotangent, we take the x-coordinate and divide by the y-coordinate. Notice that they are opposites of each other. That's going to give us -1. This is the inverse tangent of -1. So now I need to find the angle between negative pi over 2 and pi over 2 because that's my range of inverse tangent. Okay, all right, the angle between negative pi over 2 and pi over 2 that has a tangent value of -1. Well, that's this angle right here, negative pi over 4 is our answer. All right, so there is using some inverse properties to help us in evaluating inverse trig.